Step outside tonight, away from the city, and look up. You'll see maybe 3,000 stars, and between them, blackness, nothing. And you'll think that's normal. Everybody thinks that's normal. Curious? See, Richard Feynman used to say that the deepest questions in physics hide inside things so ordinary that nobody even bothers to ask about them. Why does ice float? Why do magnets push? Why is the sky dark at night? Now that last one, that sounds like a child's question, and it has a child's answer too, because the sun went down. But hold on a second. The sun is a star, and the universe is packed with stars, around 200 billion trillion of them. That's a 2 followed by 23 zeros. More stars than grains of sand on every beach on Earth, every beach. So here's the problem. If there are that many suns out there shining in every direction, in every patch of sky, why is any part of the night black at all? For 300 years, this simple little question broke the smartest minds in science. Because when you actually sit down and do the math, the night sky should not be dark. It should burn brighter than the sun. And the fact that it doesn't, that tells us something staggering about the universe. Something a poet figured out before the physicists did. Now, to see the problem, you have to think like scientists did 200 years ago. Back then, the universe was assumed to be three things: infinite, going on forever in every direction; eternal, meaning it had always existed; and static, not expanding, not changing, just there, filled evenly with stars forever. Sounds reasonable, right? Okay, now watch what happens. Imagine you're standing in a forest, a small forest. You can see gaps between the trunks, little glimpses of the fields beyond. But now, make the forest bigger, and bigger, and bigger. If the forest goes on forever, something strange becomes inevitable. No matter which direction you look, your line of sight eventually slams into a tree trunk. Every single direction. The gaps close. You are walled in by wood. Now swap the trees for stars. In an infinite universe filled with stars, every line of sight from your eye must eventually land on the surface of a star. Every direction, every point in the sky. There should be no gaps, no blackness, anywhere. The entire night sky should glow like the surface of the sun in every direction, forever. Earth wouldn't have night. Earth would be sitting inside an oven. Now you say, but wait, distant stars are faint. The light spreads out. Surely the faraway stars are too dim to matter. Good instinct, wrong answer, and here's the beautiful part. Picture the stars arranged in shells around the Earth, like the layers of an onion. Each star in a distant shell is dimmer, yes. Move a star twice as far away, it looks 4 times fainter. That's the inverse square law. But a shell twice as far away is also bigger, 4 times the surface, holding 4 times as many stars, 4 times as many stars, each one 4 times fainter. The two effects cancel. Exactly, perfectly. Every shell delivers the same amount of light to your eye, the near ones and the impossibly distant ones. Equal light, shell after shell after shell. And in an infinite universe, there are infinitely many shells. Add it all up, and the sky isn't just bright, it's infinitely bright. That's the paradox. Not a riddle, a contradiction. The math of an eternal, infinite universe demands a sky of fire, and yet you can step outside tonight and watch the darkness prove the math wrong. Now, when the German astronomer Heinrich Olbers published this puzzle in 1823, he thought he had the solution. Dust. See, space isn't perfectly clean. There are vast clouds of gas and soot drifting between the stars. Surely, Olbers argued, the dust simply blocks the light from the distant stars, like fog swallowing headlights. And for a while, everybody nodded. Problem solved. Except it isn't. And the reason is one of the most elegant traps in all of physics. Ask yourself this: what happens to dust that sits in front of an infinitely bright wall of starlight forever? It absorbs energy, it heats up, and anything that heats up starts to glow. Give it enough time, and Remember, this universe has had infinite time, and the dust reaches the same temperature as the stars roasting it. It doesn't block the light anymore. It becomes the light. The fog itself would blaze like the sun. Energy doesn't just vanish because something is in the way. That's not philosophy. That's thermodynamics. Feynman had a rule about moments like this. The first principle is that you must not fool yourself, and you are the easiest person to fool. Dust feels like an answer. It lets you keep your comfortable, eternal universe. And that is exactly why you should be suspicious of it. Others tried different escapes. Maybe the stars simply run out. Maybe the universe is finite, with an edge. Kepler believed that. For him, the dark sky was proof the cosmos was a walled garden. But a finite, static universe has its own fatal flaw: gravity. Leave it alone, and it collapses in on itself. Every escape route dead ends. The dust glows, the edge collapses, the faintness cancels out. By the end of the 19th century, the greatest scientific minds in the world could not explain the single most obvious fact about the sky. And the answer had already been published, not in a physics journal, in a prose poem, written by the master of Gothic horror. In 1848, Edgar Allan Poe, the man who wrote The Raven, the man who practically invented the detective story, gave a lecture in New York and published it as an essay called Eureka. And buried inside it is a passage that should not exist. Poe wrote that if the succession of stars were endless, the sky would show a uniform luminosity, since there could be no point in all that background where a star would not exist. And then, the leap of genius. The only way to explain the dark gaps, he said, was to suppose the invisible background so immense that no ray from it has yet been able to reach us at all. Read that again. No light from it has yet been able to reach us. Poe understood something the physicists had missed. Light takes time to travel. When you look deep into space, you're looking back in time. And if the light hasn't had time to arrive, maybe time itself hasn't been running forever. Maybe the universe had a beginning. That's the answer. That's the whole answer. Our universe is not eternal. It is 13.8 billion years old, which means we can only see stars whose light has had 13.8 billion years or less to travel to us. Everything beyond that horizon, invisible. Not because it's too dim, because its light is still on the way. The infinite forest gets cut down to a finite one. Instead of infinitely many shells of stars, we get a limited number. And the ones we have, they're nowhere near enough. Run the numbers, like Lord Kelvin did in 1901. And for the sky to blaze, you'd need stars stretching out trillions of times farther than any light has had time to travel. And every one of those stars would need to burn for trillions of years. And stars don't. They live and they die. Our own sun gets about 10 billion years. There's simply not enough time and not enough starlight. That's why the night is dark. Now, you'll sometimes hear a different explanation, that the expansion of the universe stretches distant starlight, shifting it out of view. And that's real, it does contribute. But the cosmologist Edward Harrison, who spent his whole career on this riddle, showed the stretching is the smaller effect. The deep reason is simpler and stranger. The universe is young, and the stars are mortal. Think about what just happened here. The darkness between the stars, the most ordinary thing you've ever seen, is direct evidence that the universe was born. Every clear night, you are looking at the Big Bang's fingerprint. But the story has one more twist, and it's the best one. Because Olber's logic wasn't wrong. In a sense, every line of sight really does end on a wall of light. In 1965, two engineers at Bell Labs, Arno Penzias and Robert Wilson, were testing a sensitive radio antenna in New Jersey. And whatever they did, they could not get rid of this faint hiss. The same quiet static coming from every direction in the sky, day and night. They cleaned the antenna. They evicted the pigeons nesting inside it. The hiss stayed. They had discovered the oldest light in existence, the time 0.8 380,000 years after the Big Bang, the entire universe was a glowing fog, a wall of light at about 3,000 degrees everywhere in every direction. As space expanded, that light was stretched. Its waves grew longer and longer, stretched more than 1,000-fold, until visible light became invisible microwaves. Today it registers as a whisper of heat, 2.7 degrees above absolute zero. It's called the cosmic microwave background, and it is everywhere. Point a microwave telescope at any patch of so-called empty black sky, and it glows, the whole sky, uniformly, just like Olbers said it should. The sky is not dark. It never was. The entire heavens are ablaze with the afterglow of creation, light that has been traveling since before the first star was ever born. We just can't see it, because our eyes evolved to catch a different sliver of light. So the paradox dissolves into something better than an answer. The night sky looks black because the universe is young and the stars are scattered and mortal. But behind that blackness, in a color no human eye can register, the sky still carries the flash of its own beginning. Feynman once wrote about standing under the stars in the desert. The vastness of the heavens, he said, stretches my imagination. It does no harm to the mystery to know a little about it, for far more marvelous is the truth than any artist of the past imagined it. And he was right. A poet glimpsed the answer in 1848. Physicists confirmed it with a hiss of static in 1965. And now you carry it too. The next time someone tells you the night sky is empty, you'll know the truth. It isn't empty. It isn't even dark. It's a sky full of light from the beginning of time, waiting patiently for eyes that can finally see it. If questions like this keep you up at night, good. They should. Subscribe, and we'll keep asking them together.